Vince Granato. I'm the Chief Projects Officer for the Port of Portland. This is our opportunity to really rebuild the entire entryway into the airport. So we're rebuilding the ticket counters, the concessions, the security checkpoints, all of that as an opportunity for us to really rebuild the central passenger processing for the entire building.
ZGF was brought on initially to look at remodeling the ticket hall. And in that process, the port started to evaluate what their longer-term needs were and the investment that they might be putting into the ticket hall that might not address all of their issues. There could be a seismically resilient structure put over the existing building, which would allow operations to continue throughout the construction process. And then ultimately, portions of the existing structure would be either removed and replaced with new structure or upgraded seismically so that they wouldn't fail in a major seismic event.
We had guiding principles when we went into this thing, one being the world-class design. We wanted to make sure that we were going to make a statement. We wanted to make sure it was flexible. The current building didn't allow us to make changes as the passenger processing journey evolved. This one will allow us to do that.
And then they said, okay, how do we remodel the terminal to make that work? We need to expand and then get rid of all these impediments.
So you do see wood at other airports. Typically what you see is a steel structure with wood cladding on it. Ours is completely different. Ours is a fully wood structure. No steel in the wood itself other than the girders and the columns, but the rest of it is actually the wood construction. And I think something of this scale, other airports are going to want to come and see what we've done here, especially with the environmental benefits that come from a lower carbon footprint from the wood structure.
We gravitated towards wood because that's what people think of when they think of Oregon. They think of the woods and the forests and the industry of timber. And so a walk in the woods was really a concept that resonated with the team and the owner very early on.
We've been thrilled with the joint venture between Hoffman and Skanska. You put those two groups together and you know you're going to have a great team. And they've just done a fantastic job in helping us meet our goals and really working locally with all of our partners here, whether it's the airlines, the TSA, the concessions, and certainly the port team.
Before Hoffman-Skanska was brought on board, years and years of collaborative planning with the stakeholders and airlines and tenants, port operations. They have to develop the design and concept, at least, until they brought us on board. And then we really get into developing the how. How are we going to execute the construction?
This project is probably one of the most complex jobs that most of us will see in our career. Collaboration started from day one. Planning the project, how we phase it. What are we building? How does it go together? And then how do you do that in an occupied facility? How do we space out the structure to avoid impacting the existing facility as much as possible? Collaboration was how do we get passengers around the construction, and that's where we did the bypasses. How we do the demo of the existing building to allow us to build the new roof.
In pre-construction, we developed the idea of literally sliding these roof components over the occupied terminal. And to do that, we convinced the port that a large volume of their existing terminal, which is labeled the old Oregon Market, had to be unoccupied. One of the most important things is to separate people from construction. So we ended up developing a 22-acre prefab yard. We're able to then do the prefabrication of the roof assemblies at a lower footage off the ground for ergonomic reasons and mainly to keep people safe.
We are a Dutch heavy lifting and heavy transportation company that, we do projects all around the country, all around the world. Think about the biggest thing you can imagine and we go move it. We were challenged with moving multiple panels of the roof for the Portland Airport, about 5 different kinds of pieces, anywhere from 90,000 pounds up to 1.4 million pounds. And the pieces are roughly the size of a football field. The biggest piece is 240 feet by 160 by 20 foot, give or take. 5 different panels, so everything also had to work for each different type, regardless of the shape or size. So the roof starts 13 feet off the ground. We have to first raise it to 55 feet. So then we can drive our trailer underneath. And then we move it from out between the runways to the terminal area. Once we have the modules on the trailers and secured, there's a finite window to drive it across. So we drive from the laydown yard to the terminal, maybe a mile an hour or so, a nice walking pace, something that heavy. Doesn't need to move fast. It took 2 years to build it. Set the panel down onto supports, and then pull it another 165 feet with strand jacks to launch it into its final position. And at that moment, we say, it's got to happen now. And you're over baggage claim. So once you land on that temporary tower and you're going to make the reach out to the last Y column, it's got to go right at that point.
So the project team came up with a system to design temporary shoring towers that are supported on existing columns on the structure. And then so that the structure would slide over, get jacked up and supported, slide over until you get to the final support.
You've got monitoring systems in place. We're monitoring the pulling forces, all the pressures and all the jacks. Separate, you have other companies monitoring the settlement of the piles. And you hit your window where the airport below you is closed. And that's the time where you reach out past a certain distance of the temp tower, you have to make it to the next Y column. Because anything after that, that's when everything is loaded up more than it's ever seen in its life. It's got to get to the Y column, it's got to get supported, and then it's got to get tied down before people need to be underneath it the next day.
We built the roof for 2 years while all the utilities were being removed, all the foundations were being installed, the demo was being done. All of that work was happening. We were doing concurrently, we were building the new roof. We had thousands of construction deliveries to assemble the roof at the prefab yard, thousands. But when we disassembled the roof and brought it to the terminal, we did it in 16 pieces. Phase 1 is 14 pieces of roof section, and then 2 stick-built sections at the terminal that we call mechanical modules. So the roof is broken up into what we call super modules, which is a structure, steel structure, glue lam, and then drawers which are just glue lams that fit in between these superstructures. And then we have a stick-built section. So how the roof went together is Module 1 was our very first piece that went in. We lifted it, drove it to the terminal, and then launched it over the terminal. That created our first piece.
So what holds up this new roof structure is actually 34 Y columns. You can imagine that these Y columns are representative of a tree, and they're not only used to hold up the final configuration of the roof, but they were used to help us launch the components and modules onto the new structure.
So Module 1 took us 6 days from the time we drove over to the time we set. It's just incredible technology on how we launched this roof over an existing building. The next Module 2, we drove over and we launched it in 2 days. So with all those lessons learned, Module 2 drove over one night, launched it in 2, and the second night we drove back to the prefab yard. So our learning curve really was established after Module 2. And then all we did after Module 2 was just get even better.
Safety on this particular project was really key to how we were able to get this project delivered on time. One of the key factors that we did out there is we actually built this at elevation, which means at 13 feet off the ground instead of it being at its final elevation over here at the terminal. And what that did was it brought everything down to a more workable elevation.
So one of our other challenges is actually doing this giant structure at night. Lighting, shadows, everybody can see you, but you would look down and you can't really see anything because all the light's shining on you.
Every day that I come to this project, it's amazing. I'm out here looking at this just blown away with the craftsmanship, the way it's going to look in the end. So for me, it's just an amazing project to be on because of the engineering, because of the use of the wood, the reuse of renewable resources on this project.
Not only are we fabricating something that hasn't been fabricated before, we're also going to erect it over the operational facility and ensure that there are no impacts to operations. The port is a great client, very sophisticated, and really willing to lean into opportunities for improving schedule by supporting prefabrication, which is exactly what we did with the roof structure out on the airfield.
We're making history here. And when you look at this building, everybody who's had an opportunity to work on this is going to go and say, I was part of that. It's just been an honor to work with everybody on this team. The commitment they have to making sure that we're successful in delivering this project for this region, for this community, for our customers, for our passengers, it's a once-in-a-lifetime experience, and it's just been a complete honor to me.